Hi, John Bogarts. Welcome. I'm the product manager for InstrumentStudio, the measurement framework and measurement SDK. Our esteemed Daniel Domine, who I'm sure most of you actually came to see, unfortunately is not feeling well. As of the last few days, he did take the time to pre-record his part of this. We really wish he could be here. So you will get some of Daniel's from the ether. You'll also get some participation from our other products that are running treatment and working on this. But we will get to that point shortly. Today I'm going to be talking about electronics tests, some of the key challenges involved with it, how we're using our measurement framework and measurement SDK to solve some of those challenges, and what the roadmap looks like for that product capability. That roadmap, looking into the future and the vision that where we want to take this thing, is something we're also going to give you a little sneak peek into, because at the end of this talk, I'm going to be recruiting from this group to help us build the future with this product. Because certainly, as you all know, software development without input from the users is a lot of wasted time. And ultimately, we need you to help us build this feature that's going to make you more successful. And we're very much looking forward to doing that. So just to talk about electronics test, that's a very broad statement. I want to kind of say what I mean here just as a level set up front. Here's a view of NI software portfolio. This thing changes rapidly, but you've heard a lot of talk in the keynotes about product analytics and a lot of the cool capability we have there. Test operations with System Link, a lot of functionality there. But what we've been talking about at this conference for 20 years now has really been the core of the test system, the software that actually runs on the machine. And I'm primarily talking about this layer of our software stack in this talk. And part of the reason this layer of the stack needs to evolve is because it needs to connect to these upper layers. And so in order to make that more standardized, more consistent, and easier to implement, we need to really evolve the way we think about test system software that's actually running on the machines that are capturing data. When I talk about electronic tests, we serve a lot of different application areas with NI's test system software, embedded software, testing, Veristand, physical test, is something that we serve with FlexLogger. Of course, all these applications we've been serving with LabVIEW for decades. But what I'm really talking about here is this electronics test space where we're talking about chips, modules, systems, boards, PCBs, functional tests, that kind of thing. Inclusive of wireless products that are tested in that kind of mode. The couple of people that I want to talk about, don't worry about reading the text on these slides. The point is, we've talked to a lot of test and measurement architects and heard a lot about what their challenges are, and I wrote that down. But when I think of a test and measurement architect, I'm thinking about a lot of you, people who are oftentimes the most senior person on the team, who are thinking about how do I get our team to scale beyond just this one project, but make them more efficient across multiple projects, to scale up the infrastructure we need to be successful, to stop reinventing the wheel. So that's, when we talk about the test measurement architect, we're talking about that kind of person. We're also talking about validation engineers who are doing the core job of validating a specific DUT in their projects. And they're looking at a design, thinking, how can I figure out what's wrong with this part so I can feed that back to the design team before we go to the production phase. They're also oftentimes responsible for characterizing the part completely. The production test engineer is, of course, thinking, okay, we finished the design, the part should be working as expected. My role is to filter out manufacturing defects and make sure that the manufacturing process was effective, assuming the part was designed correctly. And so, hoping that you're mainly finding manufacturing defects and not design defects at that phase. But their orientation is towards figuring out what happened in manufacturing. Now, a lot of these roles overlap. Some of you are probably validation engineers that also need to be the test architect. or similar on the production side. Some folks in some industries, the production test, is so critical, or the validation is so critical each and every product that you're doing complete test sets, and validation and production kind of merge. So I'm not claiming that these are necessarily distinct roles at every company, but just that these are jobs that need to be done in order for test organizations to scale. There's also a lot of different kinds of test systems that NI sells products that go into, or complete systems that we sell. But each of these different test systems have a lot of common challenges. Things change in terms of the device under test all the time. You're making new products. Requirements changes are driven from that. Instruments and other equipment go obsolete, forcing you to make changes in your test code. Your staffing requirements are always a challenge because that's the world we live in. We're always needing to find more help to do things and working under that pressure. And so it becomes increasingly important to be able to share the work that was done between the people you have and have a common way to do that. And of course, you're all juggling a lot of projects. So as we've started thinking about how do we improve the electronics test workflow for our customers, and how do we make things ultimately more cost effective, more efficient, more productive, we're thinking, how do we maximize test throughput? How do we maximize the impact of that test architect? How do we create autonomy for the other engineers, test engineers and validation engineers working on the program, so that we don't always need the chief engineer to come down and figure out a problem? And how do we minimize a whole bunch of the things that create problems for us, like time to set up the system and bring up a dot, time to deal with debugging and interruptions, time writing new code for problems that have already been solved, time training on new systems. So what are the characteristics of a desired solution in this space? It looks a lot like whoever comes in can use the programming language of their choice. If that's Latin, we love it. If it's Python, we also love it. If it's .NET, we love it. How can we mix and match when those preferences are different across different teams? How can I take different pieces of code from one organization and be able to use that on my team rather than recreate the IP? And other key components, how do I make my test software workflow orient around the device under test rather than all the instrumentation and tools around it? And how can I streamline the whole mental model of things so that my debug cycles go down, my code authoring cycles are reduced, and ultimately it's super easy to plug into all of the new capability that I talked about in the first slide, plugging into those enterprise data management systems and asset management systems. So what we're working on, it's a couple of different parts. The first one I'm going to talk about because it's a product that we're putting out into the world later this year, and we've been talking about this week, is the NI measurement framework, which is open, extensible architecture. It consists of three key parts: application software, a measurement SDK, and a measurement framework layer. The application software is high-level application software. No programming is really required to use the software. So InstrumentStudio and TestStand are examples in our software portfolio, but this could be your own custom application as well. The measurement SDK is the tool that we use to create measurement plugins on the measurement framework. And these measurement plugins consist of a user interface, some state management, and some underlying business logic. And that business logic could be in different languages. We've made it so that it can be distributable as a microservice. We'll talk about why that's important in a second. Daniel will. And it's parallelizable. And the measurement framework is a set of supporting measurement services that you can use when you're authoring your measurement IP, including a session manager that can handle initializing and closing your instrumentation sessions, provide you pin-centric access to those resources, a pin mapping service, And this is important for, again, having a DUT-centric workflow rather than an instrument-centric workflow. The real big problem that this solves is the portability of your measurement IP between test systems with different configurations. So by having a mapping for a particular test setup, you can change that mapping and run that same set of code on a different test system. And then we have many plans in the works for other service capabilities like functional abstraction layers and a data logging engine. But ultimately, what we're delivering in our first release towards the end of the year looks kind of like this. You can create your custom code in the center there. We provide you an interface that can send those services to InstrumentStudio for your interactive workflow and to Testan for your automation workflow. This connection between these two workflows with the same common underlying measurement IP, we think can reduce a lot of challenges on the initial bring up of the device under test, but also as you're doing debug on the floor, because the measurement underlying both the interactive and the automated experience is common. And that custom code is supported by our infrastructure layer of the PinMap service and session manager service. What I'm going to do here is I have a snippet of a demo that I want to show you just to give you kind of a feel for what this looks like and what Ryan Friedman, our product owner, he's going to show you in this pre-recorded clip is a piece of Python measurement IP that he's going to run in Testan, and he's going to show you how that same measurement can be represented in InstrumentStudio and how you can make a quick modification to it. I'll tell you, we speeded up audio to get it through a little bit faster. It's a little bit hard to hear, so I promise you'll adjust. But hopefully you can hear it okay.
I'm going to open up VS Code, which is my Python editor of choice. This measurement is actually an example that we provide to teach test architects how to write Python-based services. And so this code is also available to you once you're using the SDK. And you can see that this is a very simple file. The single Python file is actually one main function, this measure function right here, which is what we'll be modifying. You can see in this example that we are targeting an IDC power, but you can target any I/O that you have access to through your scripting. It doesn't have to be NI instrumentation at all. So I said before, we're going to add a power measurement since we've already got voltage and current. So I'm going to go to this decorator section of my measurement and define a new output. And we're going to call it power. We're going to go down to, once we have a measured voltage and current from the instrument, we're going to add a measured power variable, which is just the multiplication of our voltage and current. And then I'm going to add our new output to the output to it. Okay, so I'm going to go ahead and rerun this service with our changes. And I'm running this in debug mode on VS Code. So let's go ahead and put a breakpoint right here. Now if I go back into Testan, where I was calling this service, I can reload my parameters and we'll see a new power output. I'm going to go ahead and assign that to a variable and make sure that it's logging. And now if we run, you can see the power now in the result. And actually, you can see that we just hit our breakpoint. Now we're here in our debugging environment of choice, and we can see the values that the measure trials and checking that we want to be debugging. I'm going to go ahead and let it run forward. Sequence ends with that breakpoint, so we have to do that. And here's our new power measure. So when I go back to InstrumentStudio, you'll notice that there is no display for power. That's not an automatic thing. We intentionally create these UIs and these experiences, so we're going to have to go and modify this UI. So let's open up this new plugin editor. Plugin editor is the simple interface for creating UIs without having to code. So I'll open up the screen that we're looking at here, and let's go ahead and add a new power output. So extend my little section here, and go to the numeric indicator, we can drag that in. Got time, let's go ahead and make it look nice. And let's call that power. You see on the side of this control, I have this little squiggle. This is a connection or binding to our service. So I can say that I'd like this power measurement to reflect the output of my DC measure icon connected to the power. So if I run this, you'll see everything is now running and updating as I run. And if we go back into InstrumentStudio, it didn't update automatically. We need to go and refresh it. So let me go ahead and first save this. And then reassign the large panel to make it reload. And now we have in InstrumentStudio our new power measurement. And so that's really how easy it is to update both InstrumentStudio and TestStand to run the exact same code for your measurements.
Thank you, Ryan. So what you just saw very quickly was Ryan working on some Python measurements. He created a UI for it in our plugin UI editor. That UI can be hosted directly in InstrumentStudio, and that same measurement can be called directly from TestStand. Very cool. I'm going to pass it off to Daniel at this point.
All right, and this is now where I join you from beyond the confines of the Austin Convention Center. My name is Daniel Domene. Sorry I can't be there with you, but it's better for everybody. Ryan was mentioning during the demo that you just saw that we're using gRPC, and so I just wanted to clear that up a little bit. We're using gRPC, which is a modern open source remote procedure called framework. It's a protocol, effectively. And because it's open source, a lot of languages are already supported, which means it's a lot easier for you to add your IP across your workflow and interoperate with other systems. You can actually use anything that you write using Measurement SDK and talk to it directly, even if it's not from our application software. So this is a way that you get to reuse more and more of your software throughout. I'm going to let John talk about this.
Thank you, Daniel. By the way, when Daniel comes back here in a slide, he's going to talk through the majority of the rest of the presentation, which I give him full credit for because he did most of the work on this. There will be a slight dip in the audio between when he cuts slides, and if you know Daniel, he cuts slides a lot. I promise it's a little disorienting at first, but once you kind of catch up, you're not missing anything. The audio just sounds weird, so sorry about that. It's just a feature of the beast here. So yes, we will be coming out with two measurement framework products. The core component of this is the measurement framework itself. These are think of it as the runtime engine of the measurement framework. The measurement SDK is the tooling that you use to build on top of the measurement framework and build the measurement plugins. So the usage license will be included with test workflow bundle. The measurement SDK will be included in the test workflow pro bundle. Those are also available to add to enterprise agreements, BLAs, and things like that. So that's just to clarify, how does this actually come into your hands because of product availability? And we expect that to become available towards the end of this year. I'm going to pass it back to Daniel now.
All right, now I'm back to talk a little bit about the measurement framework future vision. We just showed you that what we're going to do with this is what we're shipping with first and foremost, where you can have your custom code connected to InstrumentStudio and TestStand and pin up service, session manager. That's all great. But where are we going with this in the future? What we want to do is take this custom code section and allow you to decompose it and make it a lot easier to compose it out of pieces that you don't have to write yourself. So in our vision is we are going to have a measurement orchestrator that can take pieces for InstrumentIO or analysis that NI is providing for you out of the box. And you can combine them and then use your own custom code to provide your entire measurement. So you don't have to maintain all of the IO code yourself. You just maintain the configurations. And then the InstrumentIO box would just do the work for you and get you the data that you need to execute in your custom code. So for instance, that can be a scope and a filter, for example, or it could also be a scope and an SMU. And if you have a scope and an SMU and you need them to be synchronized, we want to have a synchronization manager service. And this synchronization manager service needs to be extensible because we want these sync strategies to be able to be developed that know how to synchronize these two devices. And then I would provide some for the devices that we are supporting, of course. But there are cases where these devices may not be in the same chassis, they may not be in the same physical location. There is another reason your requirements for synchronization are not the same that NI has provided. But you can have a system builder create a sync strategy that is custom for that system, for that application, such that you're achieving the synchronization level that you want. In that same way, we have a session manager that is responsible for creating and maintaining all of the sessions in your system, so you don't have to manage that. And that system is also extensible, allowing system builders to maybe replace one of the pieces of hardware with something that has a different configuration, and then have them extend the session manager as well as the sync strategy. And so when you take this and you look at an entire system, what we want is for your system to have a diversity of code. Some of it's provided by you, your test architect, maybe the test engineer wrote some of it. You can have partners and system builders, everybody collaborating to make this entire system work with all of the measurements you have to take. And then all of these measurements can plug into TestStand to do what you need to do there and automate, or it can even be your own test executive or your own test sequencer that you wrote or that a partner wrote for you. Because this open architecture allows all of this to just work seamlessly. That is the direction that we're taking, to try to really empower you to reuse your IP as much as you can throughout. Now, we're talking about the measurement framework and the measurement SDK, but all of this plays into the bigger story that John was talking about at the beginning of an electronic test workflow. We understand that for the validation engineer, for the test engineer, the actual workflow, how they do their job matters. And it matters to understand how to make that as efficient as possible. And so to do this, and I, of course, like many other companies, we are doing design thinking where we have, and this is a super simplified view of this, but this is just to give you an idea of where we're at. We have a process where we start by first understanding the problem. This is what the first diamond is. And then once we understand the problem we're going to solve, we can go look at how we're going to solve it. And you can look at the diamond on the right to try to develop something and test it and deliver it. So everything we told you about the measurement SDK and the first release of the measurement framework is on this side where we're closer to delivering, as John already pointed out earlier. But I want to talk to you about the electronics test workflow. And that is much earlier in the process right now. And so when we're doing explorations, which is where we're at right now, doing big explorations of what could be a good concept for solving this, we of course take a lot of user input, and we need a little bit more. And from that user input, we start putting together some concepts. Sometimes we make a lot of mock-ups like this to try to understand what it would feel like and what it would look like to do this job that you do all the time. And so today I want to show you just a little snippet, a little peek of what this looks like. Because when we talk about the lead user partner program at the end, as John has said, this will become important. So let's imagine that we want to make this. I just talked about how we want to have the measurement be composable. And we have a measurement orchestrator, and we have a scope and a filter and custom code. How can we make a solution that solves it? And the first point is I need to set the stage of where we're at. We're talking about a validation engineer, and yes, it could be a test architect. It can be the same person. But it is a person who knows how to add measurements and maybe how to write some of them. And they want to set up the test system, bring up the part, and they want to add a couple of custom measurements to the test system. So in your mind's eye, picture an application, a brand new application. It can be anything. It's a concept. And in that application, you want to add a couple of measurements to your test system. So let's start with this application. As you can see here, is very fancy and fully done. And no, I'm kidding. But we have two options right now. We can create a new measurement, or you can find a measurement in a library. And so if we go through that path of finding a measurement from a library, what we find is the system will show all the test modules are available. It would have information that would not be in fake Latin. And we choose a test type, and when we start typing requirements, the list would whittle down, and we can then select any one of those test modules and add them to the test planner. We do that, we are able to immediately start using it and interactively validate this. So very quickly, we can grab a module that exists and just test it and see how it works and see if we like it. And if we do, then we're done. And then we can go and add another measurement. And if we don't, we can remove it and go add another measurement from the library. So let's say we did like it, and we're instead going to create now a new measurement for this second measurement we wanted to add. And to create this new measurement, because we're defining it, we actually have to have the entire template, the entire workspace to be able to do this. And that's what we're calling today. And this is, of course, a conceptual name, the measurement document. So when we create that, we have a brand new measurement document, and the measurement document has multiple stages to it that you can run through. You have a flow, you have logic and UI, and of course, where you can define the requirements. And on the top left there, you can see, almost top left, but you can see there it says Python, because you could select a different language if you wanted from here. And that's, as I said, just a concept. And we have the measure function that Ryan described in the demo earlier. That is the measure function that comes with our basic examples for Python. So let's stick to Python and let's switch to the logic. And here is the same code that Ryan was showing. Basically, this is our default example code. And it does a power measurement, so voltage and current, and it takes a couple of floats in as defined in the parameter definition up there. And we want to go back and actually compose this and bring the data in. So we're going to use the palette on the left, the one that says IO, and this has a little calculator button thing. And we're going to go drag from that, and we're going to end up with a scope and a filter, and then the measure function. So if we go back to the logic, we could now have the parameters already modified automatically for us. So we have now a data type that just comes in. It's a single data pipe that has the data that came from the filter. And then we can modify this code. And let's say that I don't like the function called measure, just because I'm me. So I want to modify that, and I'm going to call it calculate, because that just works better for me. And I'm going to add a couple more user methods, initialize and close, because I am actually going to do something with a database externally, and I want to modify these things to be able to log the data there. Once I add these and define them, if I go back to the flow, I am able to grab them from the functions palette and just drag them in. So you could compose a more complex measurement out of that just by modifying the code, and we would automatically detect that and show it to you here. For the purposes of this sneak peek, I'm just going to stick to scope, filter, and calculate. So now, if I switch to the UI tab, what I get is an auto laid out UI from those pieces. We have a scope, so the entire scope UI got pasted up here. We have a filter, so its UI got pasted here, and the calculate also gets its own UI based on the parameters that I added to the Python code. And so this is all auto laid out. I don't have to do anything to start using it. And if I want, we're assuming that we will provide you with a way to edit this layout and do it however you want. But the point is, very quickly, by writing just a little bit of code and dragging and dropping some boxes, you have a measurement that is composed and that is easy to import it, because you just have to replace those boxes with other boxes if you want it for it to not be a scope, but be a different type of measurement, for example. So if we go back to the test plan, now I have that, and I can also use it interactively, and of course I can add as many of those as I want. This is the end of our sneak peek on this, and there is a reason why it's the end, because, as I said, we're just here at the define stage. And we do want to get this, of course, to the deliver stage. We want to get that to you. And the best way for us to do that is with your help. And we need your help for this, because otherwise we are going to deliver what we think is right instead of what you need. And so that's why we have the lead user partner program that we've been teasing the entire presentation. And the idea is that we will establish a relationship between us and you. And through this open relationship, we can have a communication channel where we can just go back and forth. We can partner in active engagements, and I'll talk about that in a second, so that you can influence our product roadmap based on your priorities and your needs, and we can learn from you to make sure that our systems actually do what you need. So it's a nice symbiosis here. And what those active engagements look like, it can be anything like a field study where we go visit and we observe what your engineers are doing and learn from their needs by actually watching them do their job. We have some surveys and interviews sometimes. We want to sit down in person or virtually and literally co-design. We want to sit together and come up with ideas on what is the best way to represent something that you need and to put it in product. And then, of course, we will do concept testing of that with you and other people who are participating in the user partner program. And then once we start actually prototyping and making product, we would have usability testing. So this is what the active engagements look like. And honestly, they are not a huge time commitment. We're expecting, a couple of hours in one, half an hour in the other. This is a finite amount of time that we have. And we would, of course, agree to that time before we start the engagement. But you get an idea of more or less what we're looking for. So to give you an example of what that looks like, let's say we wanted to build a better sequencer for a validation engineer. So to build a better sequencer, we may start with a video call, and then we can go visit you on site. And yes, that's what I look like when I'm not sick. And then once we visited and saw everything, we can sit down together and start co-designing. This is what a sequencer should look like. This is why we need this. And then we can start putting some concepts together and testing them and see if it's the right thing to do. So joining is super easy. All you have to do is fill our tiny form. And we have like 3 questions. We'll do your name and your email, and that's about it. I think there is like a company and title, I think. With that information, all we will do is contact you within the next month, just with more information about our upcoming active engagements. We have one, of course. This was just a sneak peek of what we're going to be working on. So if you're interested, definitely join, because then you can help us look at all of this. And this information is definitely not going to be used to contact you for sales or marketing. This is only for lead user partner program. And with that, I'm going to give it back to John, who will.
Actually, I'm not going to do anything other than flip back to that slide so you can catch the QR code if you didn't, and then go ahead and ask you if you've got any questions so far that I can answer. But that concludes the main part of the presentation. Yes, the survey is going to ask for your name, your email, and your company. And then we will contact you and no one else, not your salespeople or marketers or anything like that. It's an R&D conversation. Yeah. Any questions? Yeah.
Are these slides available online?
They will be available through, I think, this recording. They're not available online today. But if you come talk to me, I might be able to share with you a subset of them. And certainly, if you sign up the tiny form, we will give you the long form version of this presentation, which has a lot more detail. So happy to dive into it, and in fact, I'll leave that as kind of the carrot for if you want to get in depth with this. We're happy to do that. Definitely, we're seeking that.
Okay.
Yeah. Yes.
Specific question. I'm curious. And we'll do different Sonovas. We've already started trying this out, and so far I think you're pretty tightly coupling with testing. When I see the example about the use case for a different sequencer, I'm curious that already what led to this, and maybe if you want to expand more on the roadmap of how you see this evolve.
Yeah, I think what we see, I'll state my opinion. We've had test-stand in our product portfolio since I think the 1990s. It's 2022. We think it's still the best-in-class test sequencer. But I think when it was designed, it was we put a lot of user personas that we serve in that product, including the test architect who actually constructs the sequencer itself, and people who need to use the sequencer, and people who need to just run the sequence in an operator mode, people who want to use it to maintain or debug the system. And what we're thinking about is, while maintaining all the capability of that test-stand engine and all the functionality we built into it, how do we present it in a way that is optimized for more specific use cases like validation engineering or production test development or production test deployment? And so test-stand is still the foundational technology that we're going to be using, but how do we present it in a way that's easier for new users to bring up to speed and don't get some of the overwhelm that they get with test-stand today? That's some of the things we're thinking about. We also know that many of our customers build their own custom sequencers for whatever reasons, and the measurement IP should be able to plug right into that. Daniel mentioned the gRPC interface. That's an open source layer so that we can present all these measurements in the same way we present them to test-stand. So, did I answer your question?
Oh, yeah.
Yeah, there's definitely a bigger picture there.
Is the session manager and the just synchronization manager as part of the framework? And if you can, are they?
Yes, so those are parts of the measurement framework, and you get access to the APIs for them through the measurement SDK. So the session manager and the pin map, the session management service and the pin map service will be part of the 1.0 release that's coming towards the end of the year. The synchronization manager is still further out than that. But again, we're going to be listening to you as part of this to understand what comes next. Some other components we're thinking about, for example, are parallel test capability, where I can scale to parallel test of devices just by mapping more instrument resources. We've already done that with our semiconductor test system within TestStand, so we know how to do it, and we have the technology there, and we're adding, kind of componentizing that to make it a service component that you can use in the measurement framework.
Can you see the type of synchronization in the
Yeah, so if Daniel were here, he would say he's done synchronization in hardware products and in drivers before, and synchronizing something to something else is easy. Synchronizing anything to anything else is extremely difficult. So our intent is to provide our sort of standard synchronization methodologies as part of that synchronization service. And then, as you saw Daniel presenting those synchronization strategies that can override for a particular test configuration, that's how we're going to get to both the out-of-the-box functionality and extensibility for applications that are going to be more demanding in a way that we don't have to go and do a new driver feature for each sort of combination, but you can implement it if you have a complex application.